Yeah, we're going to be talking about water. Water, and the principles as they exist. And as we know, as we've talked about in the past, we know that all principles exist within everything. And when I talk about the principles, right, it's the 7 Hermetic principles. We actually, in the vibration episode, if you haven't seen that, check that out. We talked about water quite a bit on that one. And we talked about how water is affected by different vibrations and how we are made up of, on average, 70% water, mostly water. Different parts of the body are made up of different percentages. And that's why when someone's in a bad mood, you can sense that. And that's part of the reason. It's because your water is picking up on those vibrations, what you're made of. At least that's what we're hypothesizing. And that's what we've read. You know, we've done research about water and the body. So go check that one out. That's a really good episode. Here we're going to be getting into more about just water specifically. So the structure of water, excuse me, is something like a peace sign, something like the universal theory sign. So imagine the tips of my fingers as being the hydrogen molecules. As we know, water is H2O. And then imagine the oxygen molecule being kind of where my hand is. And then my fingers would be the bonds between the hydrogen and the oxygen molecules. And because it's shaped like this and not like this, so you can imagine that my fists are the hydrogen molecules and where my fingers touch is the oxygen molecule, and that would be a non-polarized molecule. What we're talking about is this, which is a polarized molecule. So what that means is that the molecule essentially is like a little magnet. It has a positive side and it has a negative side. I believe the oxygen side is the negative side and the positive side with the 2 protons down there by the hydrogens. So we see that water is bonded a certain way, it's structured a certain way, and if water wasn't structured this way, then the body wouldn't be able to use that, and we'll see that later on. And also, the atomic number for water is 8. So just to kind of talk about how that is a thing as well as we're talking about the structure, 8 just means that it has that many protons, and then it has that many neutrons, and then if it's a isotope, it has that many. Or sorry, if it's ionic, it can have more or less electrons. So a standard water molecule is going to have 8 electrons, and oxygen has 6, hydrogen each has 1. It wants to get to 8, right? Elements want to get to a certain stable foundation, and that is having a full outer shell. And a full outer shell where oxygen is 8. And so it goes out and finds these 2 hydrogen molecules, and hydrogen is generally found in pairs of 2 in nature because hydrogen itself isn't stable, but it fills its outer shell. In that case, it's just 2 with itself, with another version of itself. So it's like, I've got one, you've got one, you know, we're being made together. Let's just quickly form a bond. So that's why you generally find 2 hydrogen molecules together. So those 2 hydrogen molecules find an oxygen molecule, and now you have this stable molecule with 8 electrons. So that's, if you hear about its atomic number being 8, then that's what's happening there. And one more thing about the structure. It's less dense as when it's frozen, when it's solid, than it is when it's a liquid. Obviously, when it's a gas, there's a bunch of energy in the molecules and they're flying all around. So this is a very unique property for water, and it's a very important property for water because life as we know it wouldn't exist the way that it does, because that means that the bottom of oceans and the bottom of lakes would freeze before the tops of lakes would freeze, therefore not allowing life to exist in it the way that it does underneath that layer of ice. So that property is extremely important for water. And you already knew that, though, because you knew that lakes froze on top. And when you drink water or you're drinking a frosty beverage with some ice cubes in it, the ice floats. So you already knew about this, but if this was any other material that I can think of, there might be some exotic ones, the solid version floats because it's more dense. So water is this thing that's the exception to the rule, and because it's the exception to the rule, it allows for life to exist as we know it on this planet.
Yeah, and it's another thing that's interesting about it is, like you said, it's going to float because it's lighter in a solid state. And, they speculate that life was cultivated on the ocean floor
Mm-hmm.
because of hydrothermal vents.
Mm-hmm.
And so, and there's a lot of life and great biodiversity at the bottom of the ocean around these hydrothermal vents.
Mm-hmm.
But also, it also acts as a buffer at the surface between
Mm-hmm.
the atmosphere and the water. So the water doesn't freeze as well because there's a layer of ice when it is extremely cold like that.
Right.
So then there's life underneath of it. Because if you're ice fishing and you crack the ice, there's going to be fish under there. They're not frozen to death.